Hello everyone, welcome back to my channel. So in this video we'll solve some more problems, okay, so of different models, okay, of course, of different models of how to find the residue. Okay, if you are first time to my channel, please consider subscribing. Okay, so to know the formulae of residues, I have done a video. If you have not seen, I am providing the playlist link in the description. So please go there, see the formulas of all the residues and come back here in order to understand all these problems. Okay, so he has asked to find the poles of e power iz by z square plus 1 and their corresponding residues. So f of z is given as e power iz by z square plus 1. So this can be written as e power iz divided by z plus I into z minus I. Z plus I into z minus I. So z is equal to I and z is equal to minus I or simple poles. Okay, they are simple poles. Therefore, residue of f of z at z is equal to z naught. For a simple pole, it is given by limit as z tends to z naught, z minus z naught into f of z. Okay, so first of all, for residue of f of z at z is equal to I. So now z naught is equal to I am taking. So is equal to limit as z tends to I, z minus I into f of z. F of z is e power iz by z plus I into z minus I. Okay, so z minus I gets cancelled off. So if you substitute I, so you'll get e power I into I. So e power I square divided by I plus I is 2I. So e power minus 1 by 2I, that is 1 by 2IE. 1 by 2IE. Okay, you can keep as it is, or if you multiply with I, so I if you multiply, and in the denominator also if you multiply with I, so you'll get 2I square E, so it will be minus I by 2E. Minus I by 2E. Okay, similarly residue of f of z at z is equal to minus I is limit as z tends to minus I, z minus of minus I is z plus I. Z minus of minus z naught is z plus I into f of z e power iz by z plus I into z minus I. So this and this will get cancelled. So just substitute minus I, e power I into minus I divided by minus I minus I. So e power minus I square divided by minus 2I. So e power minus of minus 1 divided by minus 2I. So it will be E. Okay, so E minus E by 2I. Minus E by 2I. Or if you multiply and divide by I, so minus IE divided by 2I square. So minus IE divided by 2 into minus 1. So it is minus 2. So minus minus gets cancelled. So result may be IE by 2. Okay, so you can keep like this or keep like this. Both are same. Okay. Right, we'll solve one more question on residue. Okay, same model. So f of z is equal to z by z square plus 1 is the function given for you and asked to find the poles and residue at each pole. So this can be written as z by z plus I into z minus I. Z is equal to I and z is equal to minus I or simple poles. Okay, so these are the simple poles which you have, right? So residue of f of z at z is equal to z naught for simple pole is limit as z tends to z naught, z minus z naught into f of z. So now first residue of f of z at z is equal to I. Z is equal to I is equal to limit as z tends to I, z minus I into f of z. F of z is z by z plus I into z minus I. So z minus I gets cancelled, so it will be I by I plus I. In the place of z I am substituting with I. Okay, so this is I by I plus I, so I by 2I, so I gets cancelled, so it will be 1 by 2. Similarly, residue of f of z at z is equal to minus I is limit as z tends to minus I, z minus of z, so z minus of minus I is z plus I into z by z plus I into z minus I. Z plus I gets cancelled, so just substitute z is equal to minus I, so minus I by minus I minus I, so minus I by minus 2I, so minus minus gets cancelled, I gets cancelled, so we'll get 1 by 2 again. Okay, so very simple problem, but very important problem. Okay, right, we'll see one more problem on this. Okay, so find the poles and corresponding residue values of f of z is equal to cot z he is given. Okay, so given f of z is cot z. Cot z can be written as cos z by sin z. So poles are obtained by making sin z is equal to 0. Okay, so when sin z is equal to 0, z is equal to n pi. Okay, so n belongs to all integer values. These are the singular points or singular points, right? Z is equal to n pi. So this is of the form f of z is equal to phi of z by psi of z. Yes or no? So this is of the form phi of z by psi of z, where phi of z is equal to cos z and psi of z is equal to sin z. Okay, and we have psi of z naught is equal to 0. Yes or no? Sin n pi is 0. Sin of z naught value is this one. Okay, so z naught is equal to n pi, so at n pi, sin n pi is equal to 0, and phi of z naught is not equal to 0, because phi of z naught is equal to cos n pi. Cos n pi value is minus 1 whole to the power of n, so is equal to minus 1 for odd n, is equal to plus 1 for even n, but it is never equal to 0. So it is never equal to 0, so both the conditions are satisfied. Phi of z naught not equal to 0 and psi of z naught is equal to 0. Then if these conditions are satisfied, then what is the formula for residue? Residue of f of z at z is equal to n pi, z is equal to z naught is phi of z divided by psi dash of z at z is equal to z naught, that is z is equal to n pi, of course. Okay, so what is phi of z? Phi of z is cos z divided by psi dash of z. Psi of z is sin z, then psi dash of z is equal to cos z, so this is cos z at z is equal to n pi, so both will get cancelled, so it is 1. Therefore at each pole, that means residue is going to be 1 for all values of n. So at each pole of z is equal to n pi, where n belongs to I, residue of f of z at z is equal to n pi is 1. Okay, so this is how we can find the residue of the function in trigonometric form. Okay, so if I have given with cos z, so use this formula. So this formula I have explained you while explaining you the concepts of residues. Okay, so you must be very good at formulas in order to solve any problem to find the residue of a given function. Okay.